cusp of a transformation in transportation that's being driven by four things: vehicle automation, connectivity, electrification, and sharing. And those trends are disrupting how we will provide transportation services to the community, but also the way we design and build our infrastructure too in the future. But within the next few years, we're going to see even more automation, more connectivity opportunities in our vehicles that are going to have an even more dramatic impact on the way we move around the cities and rural areas. So these things also present challenges to public agencies, but also the private sector. I'm going to just go through a couple of them. So if we go to the next slide, technical challenges. Two things I want to highlight: data management and security management. Data management in particular, when you think about the data that these vehicles are generating, gigabytes per second per day, and then communicating that data 10 times per second with other vehicles around it and with the infrastructure. Imagine the vast amounts of data that are being generated, and what do you do with all that? And then security management. How do you secure the vehicles and make sure that data remains private, but also that people can't hack into these vehicles and use them for malicious purposes? So those two issues are really important. Then there are institutional issues too. And the one that bubbled to the top when we surveyed practitioners was the funding issue. And that always, whenever you survey practitioners, they say, well, how can we implement any of these technologies when we don't even have the funding to fill potholes, for example? And then the other one I want to highlight is the new partnerships and business models, because we are entering a phase where we're looking at innovative delivery of these new technologies, but also new partnerships and business models with the private sector and with industry, because it's no longer siloed as we've been in the past, where we build roads, they build cars. No, it's an integrated system going forward, and we need to treat it that way. Go to the next slide. And then when it comes to operations, I want the top one really is the most important, and that is the workforce and educational requirements to maintain and operate the new technologies. We don't have enough technical people or the STEM education capabilities within the U.S. I mean, we rank very low internationally in that regard, and we need to really boost that up to deal with these types of technologies going forward. So this disruption also creates opportunities. And so when we look at these opportunities, I mentioned earlier the four things. Well, those are the four ACEs: automation, connectivity, electrification, and sharing. And the first one is automation. This is going to impact our operations, urban form and land use, how we design and operate our highways, green space, parking. And the bottom line is, we can't leave the future to chance. We've got to plan this out. We've got to be prepared for the impacts, both negative and positive, to support these types of modal opportunities.
So we've got 560,000 hours of delay every day, and 30% of the delay is caused by incidents. It's actually, depending on who you believe, the numbers could be anywhere 30 to 40 to 50, depending on who you look at. But it basically is, there's a significant amount caused by accidents. Right? But that's really our goal, is that we want people moving around safely, and that's where we see where the nexus is with AVs, with connected autonomous vehicles. So I'll probably whiz through this pretty fast because Jim's covered a lot of this, but we'll go to the next slide. But basically, connected vehicles, it's vehicle infrastructure. It's data that we can transfer back and forth to make better decisions from car to car to traffic signal, whatever roadside equipment. automated vehicles, so using sensors, computers to, there's a, I think there's sort of, I don't know if there's a debate, but there's sort of a taxonomy issue with the terms automated and autonomous. The public doesn't know the difference. I mean, the public goes, it's autonomous, and it's like, well, if you talk to the engineers, autonomous is, well, something that can think for itself. It gets information and it thinks for itself and they can act on it. It doesn't require any kind of, sort of human intervention. But a lot of the features we talk about in cars are automated, right? They're like cruise control. They're still something that you have to do as a driver to interact with that interface with that device. So that's where the driver assist is coming in. And when we talk, everybody knows the lane keeping, the lane assist, the cooperative adaptive cruise control, things like that, or some of those things. And then autonomous is where it just is not, they're not dependent on other things. So there's the other side of this is you can have a purely autonomous vehicle, right? You don't have to talk to anybody. I can just do my own thing, and I'm just going to go and I'm going to drive the road, and I don't care that there's another car around because I can see it. I can interact with it in that way. I don't need to have to talk to it and communicate with it in any other way. So we think in Caltrans is that the connected automated vehicle is really that's the sort of the pinnacle of what we want on the roadways, right? So that the vehicle does have the autonomy, but it's also communicating, so that it may not see something or be aware of something, but if there's something talking to it, then it can react, right? And then you go, okay, I don't see this vehicle, I don't see this pedestrian. We're working on a connected autonomous vehicle deployment plan, and we're going to have it completed by next year. And so that's going to lay out where we want to go with the infrastructure. So where do we need connected communications infrastructure? One of the things, again, back to Jim's points about data, we need to have high-speed data to some of these sites. So how do we get that? So that's like fiber optic communication infrastructure, backbone, broadband communications. We need to figure that out.